My name is Martyn. I'm a software engineer at Red Hat. I currently work on a project called Aeolus, which is an umbrella project for a bunch of cloud management tools, infrastructure management tools. Today I'm going to talk about image management in a federated cloud environment. So a quick overview of what we're talking about today. I'm going to give you a little bit of background to kind of set the scene in the introduction to the service space. I'm going to look at the typical approach that people are generally using for image management in various different clouds. And we'll look at, very briefly, some existing tools that help make the image management process a little bit easier. And then I'm going to talk a bit about one of the projects under the Aeolus umbrella, which is Image Factory. I'm not going to have a great deal of time to go into much detail. Hopefully I'll give you a high-level view and you guys can go and check out the stuff. So just a brief bit of background. So we've got a ton of infrastructure as a service vendors at the moment, which makes it increasingly important to be able to migrate from one provider to another. Differences in things like API make migration from one cloud to another particularly difficult, and there are already efforts underway to try and ease the process under projects like DeltaCloud and simply where they're trying to create a single standard interface to infrastructure as a service providers. Image management is another problem that loads on top of that. So not only do we have differences in the APIs, we also have different formats. For example, Amazon EC2 requires an API. Different providers require different types. Also, once your images are in one provider, it's very difficult to get them back out again and then migrate those images to a different provider. And also, when we're using federated clouds or environments where we're making use of one cloud, we also have a problem of trying to keep these images consistent across all different providers, so we know that the images in EC2 are exactly the same as images that we might get in our local environment. So what do I mean by image management? Well, we mean sort of building the image itself, so that'll be installing the operating system, installing packages and configuration of any image. And then we've got the cloud-specific things like how we upload to clouds, different snapshots, registration, deregistration of images, and then bring it up on the finish with deletion. So the typical approach that people are using at the moment for image management in the cloud is they all generally have some idea of what the image wants to contain. So we've got a system admin here, she's got an application that she wants to install outside the application server, and she wants to go on that inside as well. So the first thing she does is create a golden image, which will contain base operating system and any core packages that she requires. She'll then upload this to a chosen cloud provider and cloud services. Once she's uploaded it, she can register it and then she can start an instance. Once an instance is started of a golden image, to connect to it via a terminal and install the application server and configure it and so on. And then once it's ready, she'll take a snapshot, register the snapshot with the provider, ready for the deployment. So this sort of process has a couple of problems. First of all, our system admin has to deal with the specific APIs, such as uploading, starting instances, taking snapshots, and so on. And also, steps 1 and 2 here, our system admin needs to transform into the correct format that the provider requires, which in this case would be an AMI. Now there are some tools that sort of help this process make it a little bit more automated. Now step 4 here we can use some tools like Public, for example, to automate the installation of packages and configuration and so on. So that sort of describes the process for a single cloud, but in reality what most people that are using infrastructure as a service at the moment is leveraging multiple clouds. So a typical use case would be when a company wants to cloud first, they want to install some local infrastructure cloud, be it OpenStack or whatever. They all have, they deploy their instances in-house, and then once the peaks supply demand, then burst out to the different public cloud providers. So using this federated cloud approach just really complicates things. We've got different APIs across every single cloud provider, we've got the different formats, and the system admin needs to challenge data regimes. And then we've also got this added problem here of keeping our images consistent. We want to make sure that our application, when it's deployed in OpenStack, is running on the exact same environment, so our application that's also running in Amazon Web Services. So it's a traditional overhead. So instead of doing this, ideally, we'd like to have some standard way to describe our image, the operating system, packages, and configuration, and so on. Have some third-party tool build the image for us, and then translate it and upload it to all of the clouds. And we'd also like that tool to be able to guarantee the equivalence of those images across all the different cloud providers. So we know that if we've got an image in Amazon Web Services, we know it's going to be exactly the same as the images in OpenStack as well. So there are a number of different tools that will do all of this, or at least part of this for you. Two tools, Foxgrinder and OpenSUSE. Foxgrinder is actually another Red Hat project that we actually originally started using as part of the Aeolus project. And these use a chain-break-based building approach, which has its benefits. It's really fast. The restrictions that we faced when using this approach was it was really quite difficult to install operating systems that were quite different from the host running the tool due to things like differences in package manager and package management databases and so on. So an alternate approach is to use a VM, essentially start a VM, install all the operating system, configure it and so on. And this gives us much more flexibility. We can for example, install Windows operating system on a box that's in an image factory that might be on Dell. So that was sort of the one of the main reasons why we decided to spin out our own project. So I'm going to talk a little bit about Image Factory. Like I said, I don't have a great deal of time to go into much depth, but I'll give you a reasonable high-level view, and I'll introduce some other tools that are similar, also run alongside Image Factory that you might find useful. So what is Image Factory? Well, Image Factory is a tool that allows you to define your image in a standard way, and then take that image, build it, and then push it to the various different cloud providers that you require. And at the moment we support EC2, OpenStack, Rackspace, and a couple of others. So we use it actually for the image building part of it. We use a tool called Oz, which is a completely independent project. It's also sort of comes in with Aeolus as well. And Oz is a tool that automates installation of operating systems and so on. I'll send some links to the Oz project at the end of the talk, so if you're interested in just automating operating system install, and you can check out Oz and you might use that and so on. The Image Factory also takes care of the transformation of images, so it will convert any image that you have in any different format and different cloud formats required. And it also handles the upload of those images, so it actually talks to all of the APIs and just look at everything to get your images in the cloud. We support snapshot builds, so you can build images inside the cloud that you're targeting. So for example, on Amazon, you can start an instance, configure it. Image Factory will take a snapshot, register it, and so on. It also offers a standard API for things like deletion and, well, actually we group the registration and deletion as one task, and there's a standard API for that. Because of the way Image Factory works, we can guarantee consistency across providers. And provider and operating system support is pluggable, so if you find that you want to use the tool and with the cloud that you want to target that we don't support, then you can easily write a plugin and you can register through the REST API. Like I said, there is a REST API. There's also some Python client library that you can use to develop stuff. So essentially, this is what an image description looks like. This is what Image Factory requires, and it's actually an OS template. So the TDL template definition language is actually defined by the OS project that recently allow you to import this in Image Factory. So here's a really basic example here that describes an Apache web server. So we've got an operating system here, it's Fedora, to install 64-bit. We've got a link to the operating system that's going to do a network install, set the root password, and there's just a couple of basic packages that we're going to install, Apache and PHP. And then we can do some pre-boot configuration. Pre-boot essentially just means that it's baked into the image, so all the configuration is actually inside the image rather than supposed to be inside the instance. So once you've got your template description of your image, you can do the Image Factory or the REST API, which then essentially spawns OS process, which then picks out the sort of base image that we call it. It's basically a raw disk image in a particular format. Once we've got the base image, Image Factory will then transport it into various different formats. One of the cloud provider uses EC2, ANI, or what the B2 requires. Once you've got it in a particular format that you require, Image Factory will then handle the uploading of the images to the various different cloud providers. And also because all of these images are essentially created from that single base image, and we can guarantee that it's going to be pretty much exactly the same apart from the minor changes that we need to make to get it running in the different clouds. It's going to be exactly the same. So there seems to be quite a lot of OpenStack guys here, so I thought I'd quickly mention this. We actually created a proof of concept using Image Factory in OpenStack. So we extended the OpenStack Horizon UI and we added image build support in. So you can see here I've got disabled here which is Image Factory, and that's doing some stuff, created some basic mock image here. And you essentially just need to, you click on the build image button and you can simply drop in that template thing that I described in the previous slide. Click build image, that will go away, create the image for you, it will upload it to Glance and register it, so then you can be ready to start using it. I'll point to the source code and the video demo of this as well at the end of the presentation if you want to see this. So some of the issues that we're facing at the moment with Image Factory is that, well, one of the first things is that the users are essentially already locked in to the cloud providers. So it's quite difficult to try and persuade them to take a step back. It's quite a lot of effort to get their stuff out of the cloud before they become cloud agnostic. So one of the things that we're trying to do is create a set of migration tools that allow users with existing images to import them into Image Factory and have Image Factory build, so Image Factory transport those and migrate them to different providers that you're able to use. And we're also looking at integrating with a project called B2B, which is another Red Hat project. And this will essentially take, I think at the moment it's VMware and maybe one of the image format, and it will transport it into a base format that you can then use in different environments. We'd also like to be able to take existing base images and then spit out some sort of standard description, which can then be used again to create the same image in different providers, but you can tweak slightly and build the same thing. A lot of guys are using Puppet, and we'd like to be able to add some Puppet support into Image Factory for some of the configuration stuff. More off-the-shelf provider and operating system support. One of the things we're looking at is a DeltaCloud plugin. So any provider that DeltaCloud supports that can support snapshot, instance, image creation, and we can support those as well. And one other thing is in Cloud Build at the moment, if you want to do upload style build, we'll essentially build the image on a local machine and upload it to the cloud provider, and it's not particularly very scalable. So we're looking at sort of moving that process into the cloud that you want to use, so whether it's Amazon, EC2 or Nova, it just means that that's a lot scalable. So a couple of related projects. We've created a Rails engine which interacts with Image Factory. So if you want to add some image building or image management functionality into any Rails application, then you can just simply require this, drop in a couple of lines to mount the API and so on. And also some active record models as well to interact with Image Factory. Like I said, Aeolus is a tool for automatically installing operating systems. If you want to check that out, you can go to Crystal Landsets GitHub page and have a look at Aeolus. At the moment, we have quite a small sort of community working on Red Hat. There's only, on Image Factory, there's only 2 core developers. I'm not one of them, by the way. There's a guy called Ian McLaren, who's the ones that are working on this. And the project is turned into quite a beast with all of this support from different providers and operating systems. So if you want to get involved, please contact us. We've got some documentation on the imagefactor.org website, which will tell you how to write a plugin. And yeah, if you want to check out the OpenStack integration stuff that we did, you can go on my GitHub page and GitHub, and you can check out the source code. You can run that yourself. We've also got a YouTube video which shows that in action as well. So I'm a little bit early, so I guess we can take some questions. Yeah.
How efficient is the image cloning, and are you going to improve that?
So I think it depends on the cloud provider and what format it is. So like for example, Amazon, we just use the Amazon standard libraries. I know that when we were doing some support for OpenStack, we try to use the format that uses the least amount of disk space, so we've got less data transfer. But yeah, we generally use the standard tools that the cloud provider supports. Yeah.
Do you host the schema for DDL anywhere, or is it in the Git repo?
Yeah, it's in the Git repo of the Aeolus project, but we should link to that from the API.
Well, you should probably also address it as well.
Oh yeah.
That was trying to find.
Yeah.
Are there any tools that you use for generating the DDL, or I need to write it all myself?
As far as I know, and the other thing that I wrote is Catalog working on something.
Yes, I actually want to check the figuring pocket afterwards. But yes, Catalog right now, I just was redoing the design work on the configuration outlines, and one of the things you could do is you could define configuration outline in Catalog, and then there is to export it into TDL that definitely be used.
So essentially the question was, is there any tools that help you generate the template definition XML? And there's another tool, Red Hat tool called Catalog, which has some UI that helps you build those documents. Any other questions? Okay, thanks very much.